Question 1, Part E. Solve 5 over x plus 2 less than or equal to 1. Since the denominator of the left-hand side of this inequality, that is x plus 2, is a linear expression involving the unknown variable x, we can turn this hyperbolic inequality to a quadratic inequality by multiplying both sides by the square of the denominator, that is x plus 2 in brackets to the power of 2. Now x plus 2 in brackets to the power of 2 is positive. And because we're multiplying both sides of this inequality by a positive value, we don't need to concern ourselves whether we need to switch this inequality symbol around or not. Now the original inequality is 5 over x plus 2 less than or equal to 1. So by inspection of the denominator, we know that we can't divide by 0 since division by 0 is undefined. So the first observation is that x cannot equal negative 2. Now multiplying both sides of this inequality by x plus 2 in brackets squared, we get 5 times x plus 2 in brackets squared over x plus 2 less than or equal to 1 times x plus 2 in brackets squared. Now simplifying the left-hand side, we have an x plus 2 in the numerator that'll cancel with x plus 2 in the denominator. So the left-hand side becomes 5 times x plus 2 in brackets less than or equal to x plus 2 in brackets squared. Expanding both the left-hand side and the right-hand side, we get 5x plus 10 less than or equal to x squared plus 4x plus 4. Now collecting the like terms, we get 0 is less than or equal to x squared minus x minus 6. Now writing it such that the quadratic expression is on the left-hand side, we have x squared minus x minus 6 greater than or equal to 0. And expressing the quadratic expression in factor form, we have x minus 3 in brackets times x plus 2 in brackets greater than or equal to 0. Now, solving this graphically, if we graph x squared minus x minus 6, so y equals x squared minus x minus 6, we have a concave up parabola, and it crosses the x-axis at x equals negative 2 and x equals 3. Now we know that x cannot equal negative 2, which is why I used an open circle here, but x can equal positive 3, so that's a closed circle. And we're interested in the part of the parabola that's on or above the x-axis, other than the case where x equals negative 2. So x could equal a value that's less than negative 2, so to the left-hand side of x equals negative 2, or x can be greater than or equal to 3, so on or to the right of x equals 3. So writing our answer, we have therefore x is less than negative 2 or x is greater than or equal to 3. And here is the answer expressed using interval notation.